All right, guys, we are starting a new unit today. It's Module 2. We are going to be working on whole digit operations with our decimal fractions. So, addition, subtraction, multiplying, and dividing. And in the first couple lessons, we're going to be working on our mental math. So, this should be the same math book that you already have. It was Module 1 and Module 2 all in one. So you're just going to go ahead and find the new lesson 1 for Module 2. It should look like this page right here. So go ahead and get lesson 1 out materials. You'll need the lesson 1 problem set today, and you'll need the lesson 1 exit ticket. And it's in the same math book that you already have. Today we're going to be practicing using our mental math and using unit form to help us solve that. So let me go back to our video. We're going to be doing the concept video and problem set together in this video because it'll be easier to practice our mental math right with the problem set. Okay, so that's why we're going right to the problem set. So if we quickly think about these lessons, we have, what if we did 20 times 30? Well, we could convert it to unit form, and we can do 2 times 3, which is what? 6. Now, let's think about the unit, because we're still doing tens times 10. What would our tens times 10 be? Well, yeah, that would be hundreds. So we know that tens times 10 equals hundreds, so we can say 600s. So that's one way we could do it, or, and then convert this back into standard form, right? Or we could do it like this, 20 times 30, and we could say, well, it's 2 times 30, because really 20 is 2 groups of 10, right? So we could do 2 times 30 plus, oops, not plus, and then we're going to multiply that. Oh my gosh, Mr. Briggs, I'm losing my mind here. And we're going to multiply that by the 10, because we're going to first do 2 tens times 30, and then we're going to multiply that whole answer by another 10. So 2 times 3 tens is 60, and then we're going to multiply that by 10, which would give us 600. So either way, it's still the same answer, 600, 600. So we're going to be practicing different styles like that. Doesn't matter which way works for your brain, but these are different ways that you can solve it mentally in your head. So we're going to, whoops, Mr. Briggs, stylus is going crazy. But what happens if, so that was the same unit, tens times tens. But what happens if we have like, let's try, we'll do the same math, 300 times 20. So still 3 and 2 are our valued digits. So we should know that it's going to multiply into 6 something. So if we turn it into unit form, we'll do it unit form first. So it's 300s times 2 tens. Well, 3 times 2 is 6, right? But now we have to think about hundreds times tens. Well, if I had hundreds times 10, what would that give us? Or let me think about it in this way. If I gave myself a place value chart, let me give myself, label it real quick, ones, tens, hundreds, thousands. If I had 100 and I said I was going to multiply by 10, which we know just regroups, what would our unit now be? Hundreds times 10, we know that we shift once to the left. Well, the place value to the left of hundreds is thousands, so we know that this answer is going to be 6,000, or 6,000 as standard form. Okay, well, that's using unit form and using our unit knowledge and place value knowledge to solve it mentally. What about if we were using it the other way? So we have 300 times 20. So we know 300 can be broken into 3 groups of 100, 3 times 100. So what we're going to do is we're going to distribute this out to, we're going to do 3 times 20, and then we're going to take that answer and then finish it by multiplying by 100. So we're going to just rewrite this. as 3 times 20 times 100. Because 3 times 20 is a lot easier to manage in my brain than 300 times 20. So 3 times 20 is 60 times 100. Then I know that we're going to shift twice, so that's going to be 6,000. Great. All right. Now that we've kind of warmed our brains up, let's move on to the problem set. So let's go ahead and switch over to this. Let me zoom in. Get our names on it, right? So let's read the directions. Fill in the blanks using your knowledge of place value and basic facts. That's why this can be done mentally, is we use unit form and other strategies so that we can get right to the basic facts, 2 times 3 or 2 times 23 as I'm looking at this number, so that we can work simply in our brains and then put it back together. So this first one's 23 times 20. So we can see that they're turning it into unit form and they're saying 23 ones times 2 tens. So that would equal 46 tens. And we know that 46 tens has 1 0, so it would be 460. Great. Now notice, ones times tens is going to give 1 times anything, right? Gives you the original, or the identity property says that when anytime we multiply by 1, we get the same answer as we multiplied into it. So 1 times tens is still going to give us the unit of tens. So only to time like tens times tens over here on B, we should already be thinking that whatever the answer is, it's going to be hundreds, because we know tens times tens is hundreds. Well, 23 times 2, we know that 23 doubled is 46, so we know that's 46 hundreds. Well, then 230 times 20 is going to be 4,600. So, once again, this is why I love unit form, is because we can break down problems that look hard, 230 times 20, use our strategies to turn it into 23 times 2, which is so much more manageable to work with, right? But we have to remember the units that we're working with. We converted it to 23 tens and 2 tens. So tens times tens is going to be hundreds. So we know that 46 is our answer, plus the hundreds. 46 hundreds equals 4,600. All right, let's try it again on C. And it's 41 times 4. Well, 41 ones times 4. Ooh, I'm not really sure, but I can quickly do that math problem off to the right, right? Ooh. Or I can think about 41, and 41 is really 40 and 1. So 4 times 4 ones is 4, and then 4 times 4 tens is 16 tens, and that gives us 164. Well, what's ones times ones? Well, 1 times 1 is always going to keep its same unit, so it's 164 ones, which is just the answer. Now that one's a little bit more challenging to do mentally. That's why I broke it down with a number bond over here on the left, so that I could think of the 2 different parts of 41, so that I could make my life easier. All right, but this time over on D, they're going to make it a little bit more challenging for us by changing the units. And now we're working with, we can just see they kind of just take off the zeros of the numbers and figure out what unit that would be in. 41 tens. And then 4, well, there's 2 zeros, so that's hundreds. So 41 tens times 4 hundreds. Well, what's 10 times 100? Or if you think about your place value, if you shifted hundreds to the left once, that's right, it gives us thousands. Well, thousands has 3 zeros in it, so we know that this is going to be 164 with 3 zeros, and then I can place my comma in there, make sure it's not a decimal. 164,000 is our answer. I just want to say already right now that this is 3 pages. We're going to work through it quick here, and we're not doing the 3rd page with the word problems. We'll practice that later on in the unit. So go ahead and just breathe easier right there. I'm going to pause it real quick. I want you to pause it and do E and F on your own, and then come back and check your work. I should say, think about the zeros, right? That will help you. Oh, I guess I accidentally started recording again. So you may have seen that work. I didn't realize I was recording. So that's why I wasn't saying anything. But you'll see that I did hundreds times hundreds over here on the left on this one, and that created 10,000. If we take 100 and we shift it to the place values 2 to the left, that gives us 10,000. So 5 times 6 is 30, and that's 10,000s is our unit, which is 4 zeros. You can see I counted those on my number over here on the right, and that gave us 300,000. So I hope you also checked over here on E, and you got that right, or you're correcting that. So let's go ahead and work on the bottom of this page. All right, let's read the directions for this part, and it says determine if these equations are true or false. Defend your answering using the knowledge of place value and the commutative, associative, or distributive properties. So however you've been choosing to solve it, let's figure this out. So let's do 6 tens equals 2 tens times 3 tens. Well, we know 2 times 3 is 6, so that part's true. Well, now let's check the units. Tens times tens is tens? No, 10 times 10 gives us hundreds, so this is false, right? And we know this because tens times tens equals hundreds. So we know that that answer is false because that should be 6 hundredths. Great. Just showing me that knowledge right there. This is enough to show me that you know what's going on in that math problem. So let's go ahead and look at B. And it says 44 times 20 times 10 is the same thing as 440 times 2. Well, let's see if we can break this down. Well, 440 is really, whoops, let me not break down the 2. 440 is really what? Well, it's 44 tens, so it's 44 times 10. So it would be 44 times 10 times 2. Their other side of the equation says 44 times 20 times 10. Well, that's not going to do it. They're not equal, so this is false. And we can say this because 440 is really equal to 44 times 10, right? And not 44 times 20. So great job on that one. I'm going to pause it real quick. All right, I'm back. Let's keep working and see how we do on this. The next one says 86 ones times 90 hundreds is the same thing as is equal to 86 ones times 900 tens. Okay, so let's think about this. Well, 86 ones and 86 ones, that's the same. So we're really analyzing 90 hundreds versus 900 tens. Well, let's just convert those into unit form. 90 and then hundreds has 3 zeros. 1, 2, 3. So that's really 90,000. So 900 tens. So let's do this. 900 and then tens is just 1 0, so that would be 9,000. Oh man, I totally messed up. But when I did this, I was like, they're the equal, and then when I turned them into standard form, I realized, wait, Mr. Briggs totally messed up. At least I caught it this time before publishing it and having you guys tell me about my mistake, which I absolutely love. Always tell me my mistakes. I love when you guys catch them because it really tells me your understanding, and that also you're helping me fix mistakes and grow and learn and be better. So thank you so much. But I caught that one, and I'm always happy when you guys catch your own mistakes too. So 90 hundreds. Hundreds actually has 2 zeros, right? 1, 2. Now 900 tens, 900 with 1 0. Yeah, that makes sense. This is true because 90 hundreds is equal to 900 tens. And I'll just say that's equal to 9,000. Whoa, what happened to my work? Whoa. Oh, man. That looks so bad. Oh, there it is. So 90 hundreds equals 900 tens, which equals 9,000. All right, let's look at this next one. 64 times 8 times 100 is the same thing as 64 times 8 times 10. Well, let's break this down over here on the right. Well, 640 is really 64 times 10 which then is times 8 times 10. Okay, well, we have to kind of use the commutative property on this one so that we can reorder our multiplication to get the same answer. So we can say 10 times 10 is 100, which then shows us that. And then we still see a 64 in our math problem. And then we also see 8 times 8 in our math problem. So these should be equal because of the commutative property. Oops, not, I don't have to write equal. I want to write true. And we can explain that by saying the commutative property. Commutative property allows us to reorder multiplication. Now you can explain that in other ways, but it has to show your understanding of how to break that number down. Let's go to the next page, because this page is going to be practicing kind of more of the skills you'll be doing on your exit ticket. So we're actually going to skip E, and we're just going to go right into finding the products on these. And you can see they're kind of similar math problems across. So we just have to kind of show our thinking and just know that I need to see some sort of math thoughts process in your exit ticket when you're doing this. Well, so 45 times 3. Ooh, so if you need to, go ahead and do that over on the, whoops, that was bad. 45 times 3, go ahead and solve that. 4 times 3 is 12, plus 1 more is 3. So we know this is equal to 135. Now that we've solved that basic math, now we can kind of start thinking about it. Oops, sorry about that. Now we can start thinking about it's 45 times 3 tenths. I like going unit form. Well, we know that 45 times 3 tenths is 135, so we'll keep the same unit. And then that's going to give us 1,350. Sorry about that. Okay. Well, you can also do it in a different way. I'm going to keep doing unit form across this one, and we'll change the style on the next problem. And you get to choose which method works best for you. Well, with this one, if I convert to unit form, it's 45 tenths times 3 tenths, right? Again, I'm on this one, I'm sorry. I'm writing over to the next problem, so it's going to be confusing. 45 tenths, here, actually, let me draw it. 45 tenths times 3 tenths. Well, I know 45 times 3 was 135. Well, what's tenths times tenths? Well, that's where we have to use our place value knowledge. Well, that's going to be hundreds. Hundreds has how many zeros? That's right. I'm not going to mess this one up. It has 2 zeros. 13,500 is our answer. Now, for the next one, I'm going to take this math problem and put it over here. 450, so 45 tenths, times 3. Okay, that's 2 zeros, so we know that that unit's hundreds. Well, we've already solved the 45 times 3, and we know that's 135. This is where it gets tricky. Tens times hundreds. So we're shifting the hundreds place value one place to the left because we're multiplying by 10, and that is thousands. If you guys could see me when I'm teaching on my computer like this, I'm still using my hand motions to move things to the left. So even though I know you guys can't see me right now. So 135, thousands has 3 0, 1, 2, 3. So our answer for that is 135,000. Again, I love unit form for the usage or for how we can just make life simple here. And oops, I wanted to erase some of this. Get out of our way. And how it can make things simple for our brains to just solve these large problems in easier, more efficient ways. So let's go ahead and do this last 2 rows. I'm going to do C as the different strategy, and then I'm going to ask you to do the D row on your own, choosing which strategy you like. So let's go ahead and think about C in a different way. Let's break it down as 4 times 10 times 5 because 40 is really 4 times 10, right? And now we're just going to regroup. Now I'm going to let me rewrite this sentence. The commutative property allows us to regroup these in a different order and still get the same answer. So let's take this simple math. 4 times 5, which is 20, right? And then we're going to multiply that by 10, which gives us 200. Awesome. So, well, let's do the same thing. Whoops, sorry about that. Oh, Mr. Briggs, keep hitting the keyboard. 40 is really 4 times 10 times 5 times 10, right? Because it's 40 times 50. Well, again, we can regroup. Commutative property allows us to regroup, or reorder, I should say, not regroup. Reorder our multiplication. So I'm going to take the easy parts, 4 times 5, multiply them together. And then I'm going to go ahead and multiply that by the other parts, which is 10 times 10, which is also easy for my brain. Well, 4 times 5 is 20, right? And we're going to multiply that by 10 times 10, which is 100. Well, 20 times 100 is 2,000. Great. So you can see how we're doing this. Oh, man, I'm also running. I hope you guys write smaller on yours. Melanie, I know that's not going to be a problem for you. I'm going to move this one over a little bit to the left. So this is my workstation for that. Let me write the full problem at the top. Sorry that I'm running out of room. 40 times 500. Well, I can rename that by 4 times 10, right? And I can break down the 500 as 5 times 100. And then, which parts of those would I reorder so that it makes my brain work easy? Well, yeah, I'm going to take the 4 and the 5, the basic math facts, 4 times 5, which I know is 20, right? And I'm going to multiply that by, well, what's left in this sentence that we're working on? Well, yeah, 10 times 100. So, well, 10 times 100 is 1. Oops, let me write that sentence down. Well, 10 times 100 is 1,000. So 20 times 1,000, well, it's 20 shifted 3 times to the left. So 20,000 is our answer. All right, let me squish this or move it all over. Whoa, Mr. Briggs. Oh, no, that's not going to work. Let me just leave it right where it was. And then I'm going to take this math problem. Let me change colors so you can see it easier. I'm going to take this math problem and do it over here. So let me scroll this up. And we have 400, times 5,000. So it's 4 times 100. We're going to decompose it. 4 times 100, and that's times 5 times 1,000, right? Well, which parts would we put back together? Again, let's keep it simple. Let's do the basic math facts together. And then we're going to multiply that. And I'm sorry I'm running out of room. 100 times 1,000. I think you guys are getting the steps, though, I hope. So 4 times 5 is 20, right? And then we're multiplying that by 100 times 1,000. So 1,000 shifted to places 2 to the left. So we're going to place those 2 zeros of 100 behind the 1,000. That's going to give us 100,000. Well, 20 times 100,000, again, shift that 1, 2, 3, 4, 5 places. So 5 zeros behind the 20. 1, 2, 3, 4, 5. Place our commas. We know that we're dealing with 2 million. All right, let me pause this. All right, go ahead and either use the unit form or the commutative property to help you solve the next. Let me just help you with the first problem, 718 times 2. Can't really do that in your head, so go ahead and stack and multiply. 8 ones times 2 is 16. 2 times 1, 10 is 2. 10s plus 1 more is 3. 2 times 700s is 1400s. So we know that 718 times 2 is 1,436. Okay. So go ahead and use that to help you solve the rest of these math problems. Either use unit form or the commutative property. I'm going to pause. You're going to pause. And we'll see each other back when you're done with these next 3 problems. I am going to use unit form. So if you're using the commutative property, just check your answer. If it's not right, try a different method. All right, go ahead and check your work. This is a lot of thinking, and I know that you did a lot of this in your math, so you're just, or in your head, and sometimes it's frustrating for me and you guys when somebody asks you to show all the things that you're doing in your head. But please take the time to show me the steps that you're thinking in your head, because that will help me help you figure out if you're making a mistake, where exactly the mistake is. We're just building our mental math capacity, and this will be very helpful for doing so. So either you got a lot of, that's again, what I'm trying to say is that there's a lot of ways to solve math. And that's one of the reasons why I personally love math, is because it allows all of our brains to think about things in different ways. And as long as we're using sound mathematical practices, meaning that we're following the perfect steps, the right steps, and we're practicing those the right ways, things can be solved in different ways. And that's really cool to me. So, all right, guys, go ahead and shift into your exit ticket, take a picture, and submit that for me. Thank you.